Hello, this is Mark Tucker.
And this is Alan Furstenberg, and all of this is Two Voice Devs.
Two Voice Devs.
Hey,
Welcome
Mark, how
back.
you doing?
I'm doing fine. Yeah, this is man. So I feel like there's just so much happening and things are going really fast. And besides doing all the voice stuff that I've done before, which includes things like, automatic speech recognition and natural language understanding, then all this AI stuff is being thrown in,
Right.
and
Well, and
there's
first
just
of
so
all,
much going on.
so much going. I mean, first of all, let's remember all of that stuff was AI stuff to begin with.
Yeah,
It was the text to speech, the speech to text, all of the lots and lots of the processing. There was a lot of AI under the hood there already.
yep,
And I feel like now more and more of that is kind of bubbling up to the surface and being made easy to use on a whole bunch of levels. And the episodes that I did with Noble discussing LangChain, like I said then, it helped me understand just how much more there was that I don't know about this.
yeah,
And then the past couple of episodes showing clips from us trying to weed through code and get into it and understand what we can do. It whets my appetite on one hand, but makes me feel very confused on another. I don't know, are you feeling, how are you
yeah.
feeling about this?
I'm excited, kind of surprised in some ways. Like I'm using ChatGPT on a regular basis, and sometimes it's really helpful. I'm like, here's a little code sample of something that's going on in my config file. Can you explain what this part's doing, or what? I I, I don't get that quality of results coming back from when I just try to search things. Normally, because I start getting answers, very specific answers to the questions that I have, not the answers that the documentation was written to answer. And I'm like, that's really cool and surprising. And now trying to figure out how we can do that same thing for the projects and stuff that we're working on.
Yeah, I keep getting such mixed results, because I'll do that and I'll get back results and I'm like, cool, and I'll try it and it's wrong. And
Yeah,
when I then wrestle with it, and eventually I go do searches on the code that it's given me, and I get completely different results from
interesting.
Google and from Stack Overflow, and I'm like, okay, I can almost see where the results I got back from Bard or ChatGPT messed up, almost. But so in some ways it's useful in pointing me in the right direction, but I don't feel like it saves me all that much time. Maybe a little frustration sometimes, but it also
Wow,
causes
I don't
frustration
know. I
sometimes.
guess I'm having a lot more luck than
Everyone seems to have better luck at this than I am, to be
than you
perfectly
are.
honest.
But you brought out something that's kind of interesting. This thing of where it's not quite right, because it is text generation. It's not knowledge retrieval. It's not necessarily
Yes.
understand. It does a lot of times give you the eerie feeling that it's understanding, but it's making a lot of text associations, and it does what's called hallucination, right? That's kind of the big
Right.
word. And in order to ground the LLM into some reality, then you need to have some content or some data or documents, and that's kind of where vector databases
Right.
come in to help, and we can kind of talk about how that can help, but that's that's part of the purpose, is to kind of help ground the answers in reality.
Right. And you and I were kind of wrestling with, what is this HNSW database, vector, what is it and how does it work and what does it do? And kind of leverage from what Noble was talking about with vector databases. That seems like a worthy topic to discuss, to go into a little bit more depth on.
Yeah, and
I know both of us have been playing with vector databases more.
Yeah. Sorry to interrupt you on that, but yeah, but the thing is it's taken me a while to wrap my head around this idea of vectors. partly because it's not in, three-dimensional space per se. It's theoretical. It has stuff to do with math. You don't necessarily have to understand all the math to use it. But it's taken me a while to, kind of figure out, or at least come to my current level of understanding of vector databases.
So
let's talk about it and figure out what we've learned.
where do you feel like you understand it at this point? What's your level of understanding? How would you describe one, maybe even?
Okay, well, so a vector database is used to store embeddings. And so let's take a second. Embeddings are arrays of numbers that are associated to text. Well, how do you convert the text to the array or the sequence of numbers? You need to use a model, not just any model, a model specifically created for embeddings. In the case of OpenAI, that's text embedding ADA 002. There's various other models that they had before that were kind of like generation 1 models, and each for specific purposes, and they kind of combined them together and created a newer, updated model. But the idea is that with the command, you can pass a string. Let's say it's a sentence or a word or a couple of words, right? So you pass that to this model saying, I want you to return back the array of numbers that go along with that. And it does. And if you were to do that again, then it comes back with the same sequence of numbers for the exact same phrase. So it's just a mapping of a text phrase or a string into an array of numbers.
Okay. And this is something that I got into with Noble, is that the way I understand it is it's not, there's 2 steps here, really.
Okay.
It's taking that text and turning them into a bunch of tokens. And it represents those tokens. True. It represents those tokens as integers. And then for each of those tokens, creating a huge array of numbers, of floating point number, or numbers between 0 and 1.
Okay. Yeah.
So it's we talk about numbers a lot. I just want to make sure we talk about, we think about which numbers are which.
Right. Okay.
And those that vector of numbers, that array of numbers between each one between 0 and 1, represents where that token could fit in n-dimensional space.
Yeah.
Which is where most people start getting a headache. So
yeah, I just think, imagine that in a very, very simple case, it's three-dimensional space, and something's in some point in three-dimensional space and something in some other point, and you can figure out how close those 2 points are in three-dimensional space. And that I understand that it's a lot more complicated, it's a lot more dimensional than three-dimensional, but that helps me at least kind of like 2 points, how close are those points together?
No, that's exactly how I think about it as well. Is I have this, think about it as if it was, we're just dealing with 3 dimensions, and what I think is crucial is that we as humans may have some sort of association of what those dimensions are. So, when, for example, when we were talking, when Noble and I were talking, we would use an example like bank it to the left, where, in this case, we might be talking about a plane. Whereas if we used bank in other terms, we might be talking about finance or about a river. Mm-hmm. So we might say, for example, that we have 3 dimensions of planes, finance, and bodies of water.
Okay.
And when we look at how sentences go, each of these sentences, it breaks up the tokens into what's the likelihood that this fits into one of these dimensions based on the text that we've been trained with. So that later, when we say something like the plane banked left, it knows, it has a probabilistic sense along which of those dimensions it will be highest.
Yeah, and it can do that only because it's got tons and tons and tons and tons of data that it's been trained on.
Right. And it only
Now-
works, and it only works really well because it also has tons and tons and tons of vectors, tons of different thematic areas that it might
Right.
fit into.
And because of that, these vector databases could be used for what's being termed semantic search. Now, this vector databases don't have to be text. There is image, and it doesn't necessarily have to be semantic search. But I don't know if the semantic part, this is where I'm still learning, is the semantic search part something that they baked special into it, or just because of the amounts of data that it was trained on, it automatically kind of just started grouping into different things that were similar?
As I'm understanding it, it is a side effect almost of how the vector topics tend to work. So we'll think of things as semantically related simply because they are in rough proximity to each other in n dimensions. And that's a rough equivalent of what we mean when we say semantically the same. So that's kind of an interesting fallout, I think. Vector, one of the things I read about while looking into this is, talking about how vector databases are good for recommendation engines. If you think about how Netflix works, for example, the whole based on what you like, you might also like. Well,
Right.
what it's done there is it's broken up every movie into genres and subgenres and, hundreds of different dimensions for each movie, so that when it looks at all of your movies that you've liked, it can say, well, okay, here's where you are in this 100-dimension vector space. What other movies are nearby?
Yeah.
And that's kind of the same thing as semantically similar.
Yeah, and what's interesting about it is that it's all relative, right? It's just because if you were to get a result, well, the part we haven't talked about is once you've embedded all your documents, your phrases, it could be sentences, phrases, it could be paragraphs, it could be pages, it could be entire documents, whatever, chunked up and sent, embeddings created and stored in a vector database. Once you have all that done, you usually want to find something in a database, and so you're going to search for that, and you would have a new phrase or sentence. And so the idea is it's going to take this new thing, this new string, create an embedding for that, and then it's going to say, give me all the vectors that are close
Nearby,
nearby to this. So a couple of points on that is that if you're dealing with a small number of documents, it's all relative. It's just this is close, but why is it close? I don't know. It's just close, right? And so you may get stuff back that doesn't necessarily make sense. It's just less close, or close in a different way that you don't really know why it's close. Kind of my example is if I were to create a database that had embeddings in it, and not very many embeddings, but hamburger, cheeseburger, fries, cucumber, apple, programmer, truck, right? Let's say those are the things that were in there. And then I went and searched for computer. Now, programmer and apple might come closer to the top. Apple because of the computer Apple, and Apple computer and programmer. If I were to say fries, then hamburger and cheeseburger might be towards the top, but also the produce, apple might be there because they're their food, and they're so they're just, you don't necessarily know why things are close, and if you don't have a lot of data, then it might be confusing. And the number, just because like if you were to say the difference between the string that I was looking for and the string that it found is X number, right? Because you can figure out the distance between 2 points in vector space. It doesn't necessarily mean anything. It could be small, it could be big. It's all relative to the data that you have, and that number doesn't mean anything on its own.
Well, and I think using your example there, that's also where then we start talking about using, that's where generative AI and predictive text works, is that you've now taken a string, a set of embeddings, and kind of followed them along the most likely path.
Yeah.
And said, okay, what are the cluster of words that come next in this? From where we are, we've now ended up somewhere in N space. What are the most likely things to come next in N space?
Yeah.
And that's kind of, and that, gets you closer so that if the text that you've had leading up to it has been more about fried foods, the rest of the embeddings that end up getting matched will tend to be more on the fried food side rather than the hamburger or Apple computer side of things.
Right. Well, and so we started talking about databases, embeddings, and then you went to the LLM example. I think before we make that transition, it's good. It is good to, but there are a couple of different use cases. A vector database is useful on its own, just for those types of things, with like finding things that are close, recommendation engines, things that are similar to other things. You can use a vector database on its own without using, a generative LLM.
Right, and I think that's what
GPT. There's two different models involved. There's the embedding model that you have to use for both the embedding of the original content and the query that you're doing, but that is separate from the model that you could use if you chose it to use it for something with LLMs. And there's kind of a couple of strategies on how you would approach that.
No, that's an excellent point. And I think that's an important point to make to bring forward, is that these vector databases, they're relatively new, but they've actually been around for at least a little bit, and there's been some research done on them for a little bit. They're not as new as generative AI models are, but so actually I was based on our code playing around last time, I was playing with the database called HNSW, or I was playing with the JavaScript version of it anyway, and seeing what it was generating, and kind of trying to get an estimate of how well is it performed. And with that, we were using OpenAI embeddings, because I didn't have any other good embedding model, and I had this convenient API to use. And there were some interesting things that I learned in the process. So one of them is OpenAI, as I think you mentioned already, they've recently kind of condensed a bunch of their previous embedding models to a very, very straightforward one that's also pretty cheap to run.
Yeah.
One of the things that I suspect makes it so cheap, though, is it only returns 1,500 vectors. So when OpenAI talks about how ChatGPT has billions of vectors, they're reducing it to 1,500 for their embedding model. So that was interesting.
Yeah.
What's even more interesting, though, is on the test that I ran, the database index that was generated was pretty small. It was only 10 times the size of the source material, which, when you think about what it's doing, it's storing a vector of 1,500 numbers for each token.
Yeah.
That's remarkably small. So I was pretty impressed with that. And I played with that a little bit more, and it's, I was playing around with it in an LLM context mostly, but it was pretty remarkable just how well it worked for something that I could run on my desktop without requiring a ton of GPU space, except to do the embeddings, which I called an API for.
Well, and I don't know, at least from my experience, but I'm looking for your experience. Is like it's actually pretty fast, right? To generate an embedding. And then it's really just math to figure proximity. There's like different algorithms to use, but there's like cosine similarity. It's just a math problem. So it's not really having to look up a lot of things. It doesn't have to like scan the whole database. It's really pretty fast, and that's part of the reason why I think they're attractive for what the different use cases are. Is that once they're built, and you can improve them and incrementally add stuff over time, but it's really quick access to get back similar embeddings or close embeddings that are to the search term.
Right. I was going to say, one of the great things about them is that, we talk a lot about retraining models. This isn't retraining a model. This is really adding a document to a database is really a pretty, a relatively inexpensive operation in terms of both cost and time. So it's easy to add more things to your own database when you're doing this. And that's an interesting benefit that you get here. It's an interesting tool that takes advantage of some of the generative AI work that's out there now, but is far less expensive than, fine tuning a model or building a whole new model.
Yeah.
So, so which database have you been playing with?
Well, I've read a number. I guess I've read some examples on Pinecone.
Pinecone's a big one that I've heard a lot about as well, but I haven't played with that.
And kind of where this started for me though is with just following along with what LangChain's doing. I subscribe to LangChain on Twitter, and I was just like, they are just killing it.
Man, there's new releases every other day.
Yeah, I'm just like, how do you get this new stuff? And it's a bit of a challenge. I even found like there's pages that says, okay, because they support both Python and Node.js or JavaScript, right? And following along, it's obvious that the Python stuff's going faster, but they're trying to move things and make things be parallel across both of those platforms. So that's one of the things that's interesting. So what really started me on this is just a post that I saw on Twitter in April, and it was just listing all the different things that were happening, and they're making changes. And there's this category of things that LangChain can do called retrievers. And the idea of a retriever is that you have data someplace and you need to get the data out of it. So and it was doing a list of different retrievers, and what drew me to the post was it said that there are 3 distinct categories of retrievers. And I'm like, okay, I like tweets that are like that, or like posts that summarize. I'm like, okay, I can start compartmentalizing some of this stuff that just seems like it's all over the place. I'm like, okay, retrievers, and inside of retrievers, there's 3 main categories. And they said that there's the old school type, and I don't know what TF-IDF is, or BM25. I don't know.
Yeah.
Elastic search. And so I'm like, just maybe some of like old school, or maybe the things that we're used to when we do search. Then there was like the new school, which they're calling hybrid search, which they includes Pinecone, and then they include one that was managed retrieval engines, and that was Metal IO. And what immediately made me think about this, I'm like, if it's managed, then they're taking charge of the whole thing. Well, because this came along at the same time that I'm thinking, oh man, I really would like to carve out some time to better understand vectors and embeddings. So I want to create an API where there's an endpoint where I could add a document to the database, generate the embeddings and add it to the database. And then I want to be able to have another endpoint where I can search, where it would take the term that I did, figure out its embedding, and then do a search. I'm like, so those would be the two endpoints. I was just thinking, man, so what all do I need to, what am I going to use for the,
How do I do this? Yeah.
yeah, what model am I going to use to do the embeddings? What am I going to do to figure out, I have to even create so there was just a lot. I'm just like, I really want to just play with the embeddings. I don't want to do it all myself. And then I saw this, managed. Let me go check. And it is exactly that.
Wow.
You can create an account, create an index. So now they've got an empty index. You start adding things to the database. The first thing I did was that hamburger, cheeseburger, fries, apple example. Added about 20 things to the index. I had embeddings there, and I can immediately do a search through the UI or through the API, and you can be using embeddings, and it's like free up to, I don't know, something like 50,000 documents, or so there's room to grow, and it's a place where within 10 minutes I really could just jump in and start playing around with embeddings and trying to figure it out.
Now, when you say you're searching, so basically when you're putting in a document, you're putting in the text of the document and some metadata about it. And when you do a search, what do you get back? So using your example, for example, of hamburger, cheeseburger, fries, apple.
Yeah, I just get an array of JSON objects that are ranked based by closeness to my search term.
What's in the document? I mean, what's in the object that comes back? It's the metadata.
So in this case, I didn't even include any metadata. I guess technically part of the metadata is the text of the string that you created, because really the thing that's being stored is the embedding, right? So yeah, it does come back with the exact text that created the embedding, and a number, which is the closeness to the search term, is really all that it gives you back. Now there is an ability to do some additional metadata. So I could classify things as I'm adding it. I could add some metadata, and like, this is food, this is this is that. But I haven't really played around with the filtering or how the metadata would work. But the idea would be that you could limit your you could do your embeddings and get closeness, and then limit your list down to only those things that are about a certain thing in particular, if you wanted to. And
or for example, an example of something else that I saw is not so much in this case, but for example, you could put in documents and include in them the date the document was published, or the date it expires,
or the speaker, say, or
right, only give me results that were before this date. And that's that metadata isn't part of the search. It's not part of the vector, but it does change how things get filtered out separately.
Yeah.
So it's another, it's not necessarily another step, but you could think of it as another step.
Yeah.
So how did you figure out what embeddings did you use? What was the embedding engine? Or do you
okay.
pick it, or?
Yeah. So with Metal, they come with two different embedding engines. There's that OpenAI Ada 2. The text embedding one, and also OpenAI has one for images called Clip. I haven't played with that at all, but there is talk on the Discord channel. So basically, I signed up. It was really easy to get going. Didn't have to put a credit card or anything. I was able to immediately get going. They encouraged me to go to the Discord. Very responsive on the Discord. I even talked about some improvements to the UI that I thought they could make. they even, reach out and see if you want to have a chat and talk about, kind of specifically your use case, how you want to use the tool. And they're very, focused on developers and of how to create applications and projects that use embeddings, and what they want to do as far as with models. On the Discord channel they mentioned was the ability to be able to bring your own model, or some sort of a way to plug in your model. If it's not in the list of models that they support, you can still bring your own model to to their environment and use that for the embeddings, and still use them for the hosted vector database and search stuff. And they're experimenting with all kinds of things, because semantic search isn't the only thing you can do with a vector database. It's just one of the most well-known. And so they're starting to bring other, things like classification and other things that you can do with a vector database, that they're going to start bringing those as additional, functionality that you can use. So really, check it out. I think it's Get Metal, and just take a look and see what they're doing, and see how it could help what you're wanting to work on.
Very, very cool. When you actually, before you brought up Metal, before I looked into it, one of the things that I think I was thinking about vector databases was, it's kind of funny that the big three cloud providers don't have vector database as a service. And it would and that would be interesting. And then I'm thinking, and it's interesting, the only embedding API that I hear talked about is OpenAI's embedding model. And why is it that none of them have, embeddings as a service? And then AWS changed that, didn't they? So they announced, and as of the time we're recording anyway, they haven't actually released, but they announced that the Titan element as part of Bedrock will have an embedding model. And you pointed this out to me, which I thought was interesting.
So what they're trying to do is, take what they've done before with SageMaker and any of the other, AI stuff that they've done on AWS already. And even I think a lot of the learnings that they've done internally at Amazon, and are trying to let's make a service, let's make a product out of this, right? That is something that developers can use. So they announced that they're going to do 2 different models that are available, and it sounded like you could also get access to a lot of other models from other places. But the 2 that Amazon wants to bring to the table is a large language model that I think would compete with, GPT, and then embeddings, a text embedding, semantic search model. So it was going to be interesting. It seems like they're playing some catch up, to because it's not available yet, but I'm assuming it'll be some services similar to. Well, I guess I'd be surprised that if the next time Amazon has a big event, if they don't also mention, maybe a vector database that they're coming up with. I can't see them not having a vector database at some point in time.
It's really surprising, and it's we're talking about this here, so I suddenly was curious. Did Google offer it? And it does. In fact, Google's been apparently offering a vector database for over a year now.
Really?
It surprised me. This is really the first I heard about it. It is the Vertex AI matching engine.
Interesting.
Which is a product on Google Cloud. So I now need to go learn more about the Vertex AI matching engine.
Well, I wonder if there's a retriever for, or I guess a retriever for it for LangChain.
I don't know.
That it would have been one of the ones that they mentioned, but maybe not.
Well, it's also possible that it provides too much of an abstraction. It doesn't let you plug in your own embedding. It doesn't let you do a lot of stuff. But it provides this. But looking at the page, it says things like, To build semantic matching systems, you need to compute vector representations of all items. These vector representations are called embeddings.
Yeah, it
Embeddings
seems
are
like it
computed by
is.
using machine learning models. So it looks like they provide the vector database as a service, and I will need to dig more into this, I think.
Interesting. Yeah, I don't see the same thing on when I search for AWS.
Oh, interesting.
That seems like they're, they have their marketplace where you can host different things on EC2, right? So it seems like maybe there are some vector databases available through the marketplace, because I can see Pinecone listed there.
Yeah.
But I don't see a dedicated vector database as part of Amazon's offerings yet.
So, well, at least as of when we record this, who knows?
Yeah, that's true.
Who knows? It's always, always stuff is happening so fast. But it's exciting. It really, and it's easy to see how many of these tools can fit into a conversational interface and a voice conversational interface.
Yes.
So it's exciting to see what we can do with it. I really want to see what people do with it.
Yeah. So before we wrap this up, because you did mention LLMs, and I did kind of allude to different use cases. So at least right now, the two ways that I see that you can use a vector database is just a vector database on its own, with finding things that are similar to other things. The other thing is that because LLMs need some sort of a context in the as part of the prompt, or the larger context of the kind of the history or the memory, then what we've seen examples of is taking some sort of a string, converting it into a vector, hitting some documents. So this could be, web pages, or it could be, podcasts, it could be, whatever data that might be newer than was crawled by the LLM when it was created, right? Or wasn't available to access, or that's specific to what your application is about, and you can then get embeddings that are similar to that, convert that to text, back to text, and then use that text as part of the context to feed into the LLM to then ask questions or to generate text based off of, and that's kind of how it
well, what I like about this notion is that what it means is that we're using the LLM, what's the best way to put it? Almost like a translator. What it's doing is it's taking the language that we're speaking or we're writing in, and pointing us to a portion of the vector database where we can then use it to answer the questions, come up with yet another set of embeddings, and feed it back into the LLM to translate it back into English or whatever language. So the LLM isn't the source of knowledge, which, as we've discussed, it's bad at. But it is the source of communication. And that's interesting, I think. So we have a separate source of knowledge, but the two of them are tied together through this embedding.
Yeah.
So you use one to understand you, and to be able for you to understand it, and you use the other to provide the source of truth. That I think is pretty cool.
Yeah, it is pretty cool. Also, because you're dealing with a number of cost prohibitive and size limitations on LLMs, it's not like you could have your 10,000 document database that includes legal briefs or whatever. You can't just shove that into the context and say, here you go, LLMs, be an expert on this topic. But what you can do is you can filter that content down to the things that are most relevant and then use that subset of information as part of the context and then be able to answer questions or summarize or whatever it is that the
Well,
LLM is going to
again,
do.
it puts it into the contextual frame of the LLM so that the embeddings that it provides are in the correct vector space for
Yeah.
anything additional that comes along.
Yeah.
So yeah, I find that really, really exciting. So as always, we'd love to hear what you're doing on this, because honestly, it can feel pretty lonely sometimes, just, not just kind of wandering around. And this is why I love touching base with you on some of this, Mark, is to at least see where you're going and, where does it parallel or differ from where I'm going. And it really helps just talking about these ideas.
Yeah, it's helpful to kind of see how your perspective or like how you come to understand something and then kind of try to relate that to, well, that's, oh, okay, that's similar to how I, think about it, or, oh, I haven't thought about it in that way. And it
Right,
really does help to bounce ideas off of each other.
as we talked about, it seems like a bunch of episodes now, when we're learning something new, we build this mental model of it, and maybe it's right and maybe it's wrong and maybe it's good enough for now, but helping reconcile that mental model with what other people's mental models are,
Yeah.
really helps. So I really appreciate us having the chance to talk about this, Mark. This is aside from, sometimes it feels really overwhelming,
Yeah.
but when you and I talk about it, it makes it feel easier, at least not
Yeah.
so overwhelming.
Yeah, that's true. And I still feel like I'm like there's more that I need to understand, but there's also, I think, you can carve out a small enough chunk to understand it and still start to make it useful. And if you're working at tech companies that are doing things and they haven't started talking about LLMs yet, or talking about how AI is going to fit into their product, or if they haven't even started talking about how natural language is going to be something that's useful. This is all things that that we talk about, that we're interested in, and trying to figure out together how we can make this technology be applied in such a way that it's helpful, and to large groups of people, and better understand the we can handle the complexity and make something so that somebody doesn't necessarily have to understand all the complexity, but they can benefit from it.
Yep. So love to hear from you. LinkedIn, Twitter, comments below. You can find us on the Alexa Slack. Love to hear your thoughts, your feedback. We've gotten some great feedback from folks recently, and we really appreciate it. So find us there. And as always, you can find us at Two Voice Devs.
Two Voice Devs. See you later, Alan.
Take care, Mark. Have a great week.
You too.